This is the second video on the review of topic 1.1 to 1.6. All right, there's a polynomial given over here. The graph is given over here, and we need to find that where is the local minima. So local minima or minimas are the points where it's forming a valley, right? It's going from decreasing to increasing, right? There's a valley over here. So these valleys are the minimas, and the peaks where it is changing from increasing, so function is increasing here, and then it's going to decreasing. So these are the maximas. So I think this is one point which is -4, and this is one point which is 3. This is -4 and this is 3. Local maxima, like I said, it is over here where the value of x is just 0. They're just looking at for the x values here. And absolute, if they're using the word absolute, just keep in mind that it doesn't really matter about these valleys or peaks. It's just absolute means the maximum value in this entire function. That's about it. So you can see that the maximum value is right here, which is 5, happens at x equal to, I think this is 5 and this is 6, at 6. So I will say f is 5 at x equal to 6. And the absolute minima is clearly this point. This is like the minimum value of the function. Don't be confused that why is this point not a local maxima and this point is a local minima. Like I said, absolute extremas or maximum minima has nothing to do with the local extremas. Maybe it will overlap or maybe it won't. All we are looking for is the minimum or the least value of the function, which we can see is -5. And this is the point where it is -4, of course. Likewise, over here, local maxima, this is where it is changing from increasing to decreasing, or a peak, which is at x equal to 0 clearly. Sorry, local maxima is x equal to 0. Local minima is, again, these 2 points are local minima, so -3 and 4. Absolute maxima is the maximum point over here, but be a little careful, because although it looks like the maximum point is this, but look at this arrow. This arrow means that it just going, it keeps going forever. It means that its maxima will be infinity, and infinity is basically, we write does not exist, right? So um, we'll say that the absolute maxima of G, I'm gonna say, since they're asking me to write none, I'm just gonna write none, and x value is irrelevant over here because it just keeps climbing on and on, right? So the maximum value is infinity, and whenever there is an infinity, either you write does not exist, or in this case, you'll just write none. But absolute minimum is definitely there is a minimum. This point right here is the minimum, and the minimum value is -3 at x equal to 4. So here I think it's a none and none. All right. Okay, look at the arrows again carefully. Local minima, as you can see that here and here, these are the local minimas because the function is changing from decreasing to increasing. So it is happening at x equal to -3 and 1. Then local maxima is happening at this point and at this point. So it is happening at -1 and 3. Absolute maxima is clearly this point. In fact, there are two absolute maximas, right? Because both are, I mean, obviously y value is same. That's why we are saying that both are absolute maxima. So we'll say absolute maxima is 3 at two values of x. One is -5, as you can see here, and one is 3, which is right here. So that's what we have. And absolute minimum will be none because it is just a down, it has a downward arrow, so it just keeps going down forever, which means that it is negative infinity. And whenever something like this happens, we either write does not exist, or in this case they are asking us to write none. All right, the graph of the polynomial is given, which of the following could be an expression for k. It is based on end behavior as well as the roots as well as the multiplicity, right? Okay, first off, the curve is bouncing at -4. It means that the x plus 4 factor must be with an even power, because that's the only case when it bounces. Here, by the way, there is no x plus 4 in the first place, so this is just gone. You understand why it's x plus 4, right? Because x is negative 4, so the factor, this is the root, and so the factor is going to be x plus 4. Okay, this is clearly odd. X plus 4 is to the power of 1, so that's not it. This makes sense. Now, if you see carefully, these are identical in all respects except the leading term. In case A, it is negative. And that's where the end behavior comes in. And we know that it is going up and up in both the ends. So the leading coefficient must be positive and the degree should be even. Obviously, the degree is even because x square we get from here. So 2 from here, 1x from here, 1x from here. All are in product, so I'll just add these. So even power. And like I said, it should be a positive leading coefficient because it's going up, up. So it has to be option B. That is the correct choice. Let's use the same strategy here. Nothing is odd by even, by the way, because even at -3 or at 0 or at 2, it is passing through, right? It's not bouncing. So option D is just gone because there is an even power over here, but I don't see any bounce. All right. Now, this does not have x in it, which is not correct because x has to be there because x equal to 0 is a root. So x is a factor. So it's either B or C. And then you can see that its end behavior in the right direction, it is going in the negative direction. In the right side, as x approaches to positive side, it is going down. It's declining, right? So it has to be a negative leading coefficient because try to think about it like this. If you put x as 5, let's say for example, all these numbers will be positive, but then we multiply with a negative number. So this entire thing will become negative, which is true because at 5, the function will be somewhere here, which is obviously a negative number. So it has to be option C. All right, likewise here, the function is bouncing at both these points. So this is x equal to -2, this is x equal to 3. So at x plus 2 and x minus 3, the function is bouncing, means even powers. This is clearly not the case. This can be it. And where is x square plus 1 coming from? That's interesting. That's interesting. All right. Let's figure this out because otherwise the conditions are still matching. Now let's talk about the end behavior. So it is going in the plus direction in both the sides. So the leading coefficient must be positive. So it cannot be C because here there's a negative sign. Now, which one is it, B or D? A very simple way to find. Let's try to work on. So actually I overlooked because this is like x minus 2. And x minus 2 really cannot be the factor, right? I thought about this as x plus 2, but yeah, this is not x plus 2. This is x minus 2. So that's not correct. The answer is definitely D. If you're wondering that where is this extra term coming from, uh, this particular function could have some complex roots because it is not generating any real root, but it can have complex roots, right? So D is definitely possible. Okay. We need to find where G is positive. That's pretty straightforward. G is positive in this direction, in this region, then again here, here, all the way. So my answer, but since there is an arrow right over here, so I'll say it's from negative infinity to -2 because -2 is here. And -2 should be a parenthesis because it is greater than 0, not greater than equal to. And as you can see that the function is 0 at -2. Union -2 to 3 and again parentheses. And it is negative when this happens. So it's from 3 to infinity. Once again, it's pretty similar. Less than equal to 0 is here, here, all the way. and greater than 0 is over here, this portion. So less than equal to 0 will be, and less than equal to 0 means I can include the roots as well. So I'll put a bracket, -3 to, in fact, 4. I don't really need to break it down at 0 because 0 is already included. And hx is positive when it is negative infinity to -3 union 4 to infinity, That's about it. Okay. We need to solve these inequalities. Right. So I think let's start with the first question. I hope you remember how to do this. So the way we do these questions is first we make sure that the leading coefficient is positive, which it is in this case. The next step is we plot the roots. So from here, -4 is a root. From here, -1 is a root. And from here, 3 is a root. And then we plug in numbers of our choice in 1, 2, 3, 4, these 4 regions. For example, any number greater than 3 that you like, maybe 100. If you put 100 here, this entire thing will become positive. And I told you in that particular video, I told you a shortcut that if all the factors have odd powers, in this case, all are powers of 1, so 1 is odd, then just find the most right and then toggle the signs. So plus, minus, no need to test the points in this region. They need greater than equal to 0, so my answer is -4 to -1 because, at these points it is 0 as well. 0 is allowed. Union 3 to infinity, that's my answer, right? Okay. Likewise, over here, the only change is you first have to make this leading coefficient positive by multiplying a negative sign both the sides. So the moment you will do that, the sign will switch. Less than 0 will become greater than 0. And now you pretty much follow the same strategy over here. So I'm pretty sure you can do it. If you want, just post your answers in the comment section and I'll see if that's correct. Okay, between these two, I think I'm just going to do this one, question 14. So let's find the roots first. It's already the leading coefficient is positive, so the roots are going to be -5, -1, 6, 6 is here, and then from x I will have a 0 right here. Okay, it is greater than 0. So I'm going to put any number greater than 6, maybe 100. So if I put 100, obviously everything is going to be positive. Now, don't you think that while I test the points, I'm not really bothered about these two um, factors, because these are squares and doesn't matter what you put as x, it is always going to be positive. Obviously, I'm not putting -5 or 6, otherwise you can argue that it will become 0. That's right. We will put in this region, so it will never go 0. It will always be positive. So if I want to test the signs, I'll just test the signs in the factors that are with odd powers. So our focus will be on here and here. Okay. Between 0 and 6, let's pick a number 5. So 5, positive, positive. That's about it, positive. Between 0 and -1, maybe -0.5. So -0.5 will make this as negative and this as positive. And positive times negative is negative. So this is negative. Here, let's say -4. So this is negative, double negative is positive. And here, let's say -100. So negative, negative, and then positive, double negative. They need positive, so my answer is -infinity to -5. Remember, you need to break at -5 because equal to 0 is not allowed. Union -5 to -1, union 0 to 6. That's the answer. All right, I'm pretty sure you can handle these questions, so I'm going to skip these. Okay. Find all the real zeros and indicate multiplicity. That's pretty straightforward. If you remember, okay, zeros, I think you very well know, just equate these expressions, these factors to 0 and get the values of x. So from here, you will get x equal to 3. The next one is x equal to -2, and then x is equal to 1. Multiplicity is just the power of that factor. For example, x minus 3 factor has a power of 4, so multiplicity is 4. And rest of these, there is no power, means the power is 1, so the multiplicity is 1 as well, right? Likewise, over here, the zeros are x equal to 0, x equal to negative 3, and x equal to 2. For 0, the multiplicity is 1. For minus 3, the multiplicity is 1. And here, the multiplicity is 3 as well, because the power is 3. Not as well, the power multiplicity is just 3. Okay, here x is 0 from here, and then x is negative 2, and then x is 6. So the multiplicity will be 2, the multiplicity is 3, the multiplicity is 2 once again, so the power of 2. Okay. Here the zeros are x equal to 0, x equal to negative 7, and x equal to 3. The multiplicities are 3, 2, and 1 respectively. All right. Again, the same question. So I think I'm just gonna skip this question. I'll do this question for you because 20 is a little more, uh, requires more work than 19. If you understand 20, you can do 19. So here we need to factorize this as much as possible, right, into linear factors. That will help us to determine the roots and especially multiplicity. So it can be written as negative 2x, that remains as it is. X squared minus 4 is x minus 2 times x plus 2. And x squared minus 4x plus 4 is x minus 2 whole square, because that's a perfect square. And x squared minus 2x minus 8 will be x minus 4 and x plus 2, right? That's the factored version. Let's try to club the like terms. So negative 2x remains as it is. 1x minus 2 is here, and 2 are here. So if we club these, it will become x minus 2 cubed. Then we will have x plus 2 square, and then we will have x minus 4. Why x plus 2 square? Because 1 and 1. Now it's pretty straightforward. The roots are x equal to 0, x equal to 2, x equal to negative 2, and x equal to 4. And the multiplicities are m equal to 1, 3, 2, and 1 respectively, right? Okay. Let me do this question for you now. So here I think I can take x as a common factor. So if I do, I'm left with x times x squared plus x minus 12. Here I can take x squared out again. So x squared times x squared minus 9. So this will become x times x plus 4 times x minus 3, because I'm able to factorize this. And this will be x squared times x minus 3 times x plus 3, right? And if we club these things up, so x times x squared will be x cubed. X plus 4 is just only 1. There are 2x minus 3, so whole square, and then 1x plus 3. So the roots are going to be x equal to 0, x equal to negative 4, x equal to 3, and x equal to negative 3. And the multiplicities are 3, 1, 2, and 1 respectively. All right. Okay. I think I'm gonna skip these questions. Is this, yeah, it's just a fact. Maybe I can do this one, because this is a quadratic with a leading coefficient not 1. So just to remind you how to factorize these quadratics. So we make an x here, then negative 6 times 3 is negative 18. The b value is negative 7. What are the two factors here? It's negative 9 and 2. So we split the middle term, so it looks like x squared remains as it is. So it's 3x squared minus 9x plus 2x minus 6 times x taken as a common factor, and I'm left with x minus 3. So x square, here 3x is taken as a common factor, I'm left with x minus 3, and then plus 2 is taken as a common factor from here, and again I'm left with x minus 3, so that x minus 3 is taken as a common factor from this entire thing. And then club the terms, it will become x cubed 3x plus 2 x minus 3 whole square. So the roots are x is equal to 0, x is equal to negative 2 over 3, x is equal to 3. The multiplicities are 3, 1, and 2. All right. Okay, end behavior as a limit form. So they are saying that when x goes in the left direction, the function goes in the negative infinity side, means like this. And when x goes in the right direction, the function also goes in the negative infinity side. So this is the case when the degree is even and the leading coefficient is negative, right? This is the case. So this graph happens when polynomial has these properties. So even and negative is option C because degree is even and the leading coefficient is negative. Here when it goes, x is in negative direction, gx goes to infinity, so climbs, and here it goes down. So this is the property when this happens when the degree is odd and the leading coefficient is negative. So odd and negative is right over here. That's the answer. Right, it's a similar question. I'm pretty sure you can do this. Let me do 28. All right. Here we are given a polynomial and then we have to match it with the end behavior. So what is the degree of the polynomial? 4. And what is the leading coefficient? Negative. So even and negative means down, down. So both are going to negative infinity. That's actually option A. That's the correct answer. All right. The table shows values for a function f at selected values of x, which are the following claim and explanation statements best fit these data. Okay, so this is about the ROC, right? So we first make sure that x values are increasing with the same value, which it is. And then we find the rate of change. So -5 minus minus 2 is 1. 3 minus minus 1 is 4. 10 minus 3 is 7. 20 minus 10 is 10. First difference is not constant, so it's not linear. Let's find second difference. So 4 minus 1 is 3, 7 minus 4 is 3, 10 minus 7 is 3. So yes, second difference is constant, so it has to be a quadratic. Why? Because the rate of change over consecutive equal length input value interval is constant. No, that's not correct. Because if the rate of change would have been constant, that would have been a linear function. But actually the rate of change is linear in nature, right? This rate of change, this ROC is linear in nature, and that's why its rate of change is positive. Right? I hope you understand. This is forming a straight line. This is linear, and that's why it is option D. That's the correct choice. The table shows values for a function h at selected values of x. Which of the following claim and explanation statements best fit these data? Okay, once again, concave up and concave down. So we have to find the first difference first off, which can also be realized as ROC. Okay, x values are increasing by 10, so all good. 60 minus 100 minus 40, 40 minus 60 minus 20, 30 minus 40 minus 10, 25 minus 30 minus 5. And you can see that the ROC, these ROC values are increasing because lesser negative number is a bigger number, right? So it is increasing. So whenever ROC increases, it is concave up. Why? Because the AROC are positive? No, I don't think so. That's not the correct explanation. AROC is increasing. Yeah, there you go. AROC, average rate of change over these intervals, are increasing in nature. Has to be option B. Working on the attributes here, function is positive. No, clearly the function is not positive. It has a negative aspect as well. The function is negative. No, the function has a positive aspect as well. So A and C are just gone. The rate of change is positive. Yes, absolutely. And here the rate of change is negative. No, because rate of change is positive means the function is increasing in nature. Absolutely correct. And rate of change is increasing is also correct because it means it is concave up in this case, which is also correct, right? So B is the best choice. G is an even function or G is an odd function? It has to be an even function because it is symmetric about y-axis. And whenever it is symmetric about y-axis, that is the property of an even function. And you can see that it is a concave down function, which means that ROC is decreasing in nature, right? ROC is decreasing means it is concave down, so it's B. Right, over here, is the function increasing? Yes, definitely the function is increasing. I can clearly see that the function is climbing in nature, so it has to be increasing. And it is concave down, so ROC is decreasing. There you go. ROC is decreasing, so it's B because it is frowning face. Here the function is decreasing clearly, so nope, not increasing. And it is concave up. Concave up means increasing rate, or ROC is increasing. So it is decreasing but at an increasing rate because it is concave